Let me get a sense of what people want to know, what you want to learn here in the next little bit. Silverlight DRM support, I will not be talking about at all. I'm sorry. It's a great question, though. I'm very curious myself. You question back there? All right. Yeah. There's, if I didn't get a press release, I can't talk about it today. But, so, I think it's a great idea. Live streaming, yeah, well, so you can talk about it some. It's working great. I'm not going to be demoing live streaming right now. There's going to be a session on Friday where we'll be demoing live streaming with 4 real-time cameras and everything. Okay. The Charles and James session on Friday morning at 8 o'clock, which is a real true Vegas test, but it will be awesome enough to merit your attention and your hangover. I saw their demo. They're doing 4 cameras, real-time switching, video clips, trailers. It's amazing. So it's working great. The nice thing about Silverlight is it just plugs into Windows Media. Windows Media has long been the most robust real-time streaming technology for live stuff. So all the stuff that worked before keeps on working great. Yeah. Silverlight video on an iPhone. Yeah, I'm looking forward to Apple releasing that SDK. So the interesting news is that someone did a teardown of the iPhone, and the iPhone has a video decode chip in it, and that video decode chip does VC1 decode. So there's hardware support for Windows Media in the iPhone. So it just, whether Apple opens that up for us or not in their SDK. But if that gets in there, that'd be pretty exciting. But Apple being Apple, not like we get a lot of good, juicy rumors in advance of what's possible there. And broadly speaking, obviously, portability is an important thing for us. So we announced Windows Mobile and Symbian support today, 2 very high-volume operating systems for that. So a lot could be possible down the road. Like to see it everywhere, but that's really up to what Apple exposes. Steve Jobs, I think I saw announced today that Flash for iPhone is not coming soon because they felt that Flash wasn't architected right for it or whatever. So, see what that means. All right, anyone else with a burning question they want to hope it? Yeah. Optimizations for animations, like cell animation, or? Mm-hmm. Mm-hmm. Awesome. Cool. I'm actually going to, one of my 3 demos I'm doing today is screen recordings, which are kind of like animation. So I'll show you some tricks about using the B-frame setting and Chrome Assert and some advanced features. But yeah, the VC1 codec is really good for doing animation content. We've done a bunch of it for the HD DVD and Blu-ray titles, and all that carries on there. So you actually can... You're right. Do any animation in Silverlight? All right. Good. Sorry, DRM guys, but we'll have lots of other good stuff coming here for everyone else. All right, so today I'm talking about kind of a broad view of the delivery mechanisms for Silverlight video, the streaming side of things, hosting options, what's happening in Server 2008. I'm going to show you some actual hands-on things with the friction encoder, 3 different scenarios of using it in a couple different ways for offline encoding. Then talk about some of the more advanced features, drilling down some of the advanced codec features, that kind of stuff. So depending on your level of nerdiness, I kind of try to do a little kind of nerd pyramid thing going on here. So if you're at the sharp point of video nerdiness, you'll like the end of it. So if you, I'll give you clues when you can leave if I'm too esoteric for you. So kind of the 2 broad goals of all this is we want to be able to deliver content with compelling quality. So whatever the situation you're in, if it's a device, if it's a desktop, it's a laptop, you have a lot of bandwidth, you have a little bandwidth, you are awesome for that environment. In that you have awesome media for your target space. I also want to talk about how do we maximize return on investment. How do you get good-looking video done quickly, inexpensively? How do you be able to do a high volume of video, minimizing labor costs? How do you not spend a lot of time with trial and error, re-encoding and re-encoding and re-encoding? How do you get it right the first time? So the idea is awesome stuff done with a minimum aspirin budget. So. Starting off here, going to talk about the way video gets delivered. Traditionally, we've had 2 modes we've always talked about in the streaming industry. We have progressive downloaded streaming. We've had that in Windows Media for a long time. Silverlight inherits that. Progressive downloads the traditional kind of web way of delivering video, like what YouTube uses, where just it's a HTTP thing, starts copying it all down there. It's very simple. Comes with a normal web server, but it doesn't give you a great random access experience for like a 2-hour movie. You have sort of buffering happening sometimes, all that. The other mode we have is streaming, where it's a dynamically managed connection with a lot of conversation happening between the player and the server to figure out what's the best thing it can deliver at a given time and all that. So typically in the streaming environment, you expect better random access, lower latency, and also streaming lets you do live. You can't do live with progressive download because you can't be pulling down a file that's still being written to off a web server. So streaming is really required for live. Also, it's really good for mobile devices. It doesn't require caching. You're on a mobile phone, which has got maybe 80 megabytes of memory. You're trying to watch a 2-hour movie that's 200 megabytes on the server. You ain't going to cache that on your device. So by streaming, you're able to send the data down and have it discarded immediately. And that's going to work pretty well. So traditional web delivery mechanism, it says, give me a file. Oh, you're there. Give me the file. You're good to go. That's all it takes. Dirt simple. So progressive download, pros, it's easy to manage and configure, just a web server. If you have any kind of web hosting facility available, you can do progressive download. Server, you can do a lot of stuff off of it. You're limited to how much bandwidth you have. There is SSL support, so you can do encryption in the sense of you can deliver content to someone without someone in the middle being able to access those bits, but you can't really secure it from the end user. So it's fine for a corporate environment where you trust who you're delivering the bits to, but it's not a great solution. You're trying to protect content from being redistributed. Works everywhere. Big problems, no live broadcast. Fast forward, rewind experience. We're working on that. It's better than it used to be, but it's still not great. If you have a slow connection to a really big file, it can take a really, really long time to buffer and download and all that. But no worry on that. In the streaming world, you have a much more complex protocol. There's a header that kind of describes the file and asks about it. What's the response? Tries to set it up, all that, and all this kind of stuff. So a lot more goes on there. It's a lot more advanced. The good thing is it's really, it's a pretty deep protocol designed to deliver media in a really quick fashion. Advanced stuff, you get your bandwidth optimization, tries to take advantage of the bandwidth you have. It can do some bursting in some cases, all that kind of stuff. And really the critical thing is it's the only way to get live delivered. As Scott mentioned in the keynote this morning, the big reason why NBC went with Silverlight and Windows Media for the Olympics is because we've been doing great live for years. And that was obviously a very important scenario for them. Cons, you have to have a separate whole infrastructure for it. The same server can do both, but it's more stuff to deal with there. And also, in the end, if you have your file delivered at a certain data rate and they have a lower speed connection, they don't get buffering, they just don't really get video. You might just get a frame every few seconds and some audio or something like that. But you really have to make sure that you have content encoded at a data rate that's less than the available connection speed of the customer, or else things can go south pretty quickly. So kind of just I think of some scenarios you want to go for. Pretty much WMS, so streaming, can do everything. Pretty much all scenarios. A web server of IIS, so some things you can't do. Live content, program broadcast kind of stuff, live webcasts. But generally speaking, for most kinds of delivery of on-demand content, you can go either way. And there's no real one right answer. It really depends on what you're trying to do. A couple technologies that are part of Server 2008 we're delivering with that is one of the IIS-7 Media Pack. It's really about improving the progressive download experience. It's a free download that works on top of IIS-7, offering bitrate throttling. And that's part of the keynote today, where the idea is you'll send the first chunk of data down really fast, so they start playback immediately. But then, there's no reason to, if it's a 2-hour show or whatever, there's no point in sending all 2 hours of video in the first 5 minutes if someone's going to cancel watching 3 minutes through, and you just waste all those bits. So it gets them what they need to start playing quickly, down quickly, and then sends the bits they need as they need them down the road. That's going to keep them from spending all the consumer's bandwidth all going to this big download instead of other things they might want to do, and also saves a lot of money on distribution costs. Also a web server playlist functionality, which is so awesome I can't describe it here in terms of how lengthy it is, but Ed Maya's got a session later on in the week. We'll go ahead and do it. The idea is you can kind of give a list of items to watch. And let's see, in the progressive download environment, making sure people have seen things like the advertising before they go on to the next clip, that kind of stuff. So people can't kind of just grab the assets they want to get out of a playlist. So a lot of what's happening here is they're trying to bring some of the advantages that used to be streaming only into the progressive download world with the media pack. So it's able to support better random access, the bitrate throttling, that kind of stuff. So it's really trying to close the gap between a progressive experience and a streaming experience. So, and it's doing that. It's a free download for any SKU of Server 2008. So, where was I? Oops. Whoa, how are we going here? Oh. You have to watch my animations again, sorry. We'll get there. No, I don't. I hit the end button again, it's not my keyboard. All right. So streaming, all right, next level. Oh, no, I did that already. I did that. Okay, so media distribution options you're going to have for content is, one is you can outsource it. Generally speaking, if you're trying to deliver content to the public, you're better off outsourcing the media distribution, in the sense of going to some kind of a content distribution network to deliver the bits. Just because if you're trying to do it off your own servers, off your own bandwidth, in the case where you need to be provisioned for as many users as you could possibly ever want to have at one time. So it's one of those things, if in a given year you have that one event where you need, a terabit of bandwidth, and then the rest of the time you use a lot less, it's really expensive to have enough at that one point. And the CDNs also have distributed servers around different regions, so people, other continents can get the content pretty easily, that kind of stuff. That's an appropriate way. We have our silverlight.live.com, Silverlight streaming service is available. And of course, all the major CDNs in the industry support Windows Media and have for a long time and do a good job with it. Doing it yourself, Server 2008 is certainly an option as well, with IIS7, the Media Pack, Server 2008 for doing streaming stuff. And that would make sense in an internal LAN WAN environment where you're basically your own high-speed internal networks goes there. Server is very scalable. You could often do thousands of streams of a single box. Works well. There's some hybrid model where you use what's called an origin server, which is the box inside your network that does everything, and then maybe remote people trying to log into that. They can then feed to a CDN. So your internal customers get to watch it off internal servers. People in the external world then get a CDN version of it, and everyone gets kind of the ideal option there. So Windows Media overall, so Silverlight uses Windows Media as its primary audio-video platform. I'll support the MP3 audio file format at this time. I really think Windows Media today really got defined with Windows Media 9 series in 2003. And we've had a whole lot of improvements in codecs for both video and audio and other kinds of technology things, but they really defined a really nice interoperable set of technologies in 2003 that works well. And it means it's mature. It means there's a lot of files out there that are already Silverlight compatible, a lot of servers that are already Silverlight compatible. So we see a lot of interest in the enterprise migrating from existing Windows Media systems, and they're able to use their current content libraries and their current servers, and then just add Silverlight to do the final web experience of it without having to re-encode everything. Scales from phones and high definition. We have, obviously, Xbox Live Marketplace doing high-def downloads of the Xbox. We have phones playing back Windows Media content, so it works on a wide variety of devices. Which is important as we take Silverlight to a wide variety of devices as well. Obviously, phones is an important thing. You really see Silverlight as the future of the Windows Media format on the web. When you're in a browser-based experience, Silverlight provides much, much richer functionality for how you get video to happen in a web browser than we had before, while still being compatible with existing content. So some of the things about the whole ecosystem. We have a lot of mature live streaming encoding tools, all the way up to broadcast-grade rack mount systems. There are companies that will sell you 1U, remote managed embedded OS boxes that do great Windows Media content that's compatible with Silverlight, also compatible with IPTV delivery. So it's really carrier-grade kind of technology. It's not a laptop running a piece of software, but really stuff that's meant to run without rebooting for months on end. We already have HD streaming working well. We've been doing HD in Windows Media for about 4 years now, and you can stream to it if you've got a fast enough network for it. The US is not quite there for streaming HD, but other countries actually have the bandwidth, and it works pretty nicely. There's also a big ecosystem of offline encoding tools. We've had an SDK available for many years. It's been free to partners to let them incorporate Windows Media in their tools. And pretty much every major compression product out there has built into it great Windows Media support. And we've even extended that into the editing platforms. The major editing tools typically import and export Windows Media content, either built into it or the third-party plugin like Flip for Mac. So even Final Cut users are able to both ingest and author Windows Media on their platform. So good stuff there. That really has helped make Windows Media a great technology because there's so many tools around it, so much legacy of tools and services in it. So why for Silverlight, Windows Media, and VC1? Big thing, great quality, great efficiency. We'll see some samples in a little bit in terms of both the video and the audio. But we deliver, you get a view of in compression, kind of quality and efficiency is kind of two sides of the same coin. That when you make it more efficient, you're able to either give someone the same experience at a lower bit rate or give them an improved experience at the same bit rate or somewhere in between. So every time you make the codec better, it gives you more flexibility how you deliver it. So, and we feel Windows Media with VC1, we've done a great job of giving you great video experiences. In Windows Media with the Windows Media Audio 10 Professional Codec, which we're announcing support for in Silverlight today, extremely good audio performance, about twice as efficient as we had in the previous version. We also have better decode performance. The other major codec right now is H.264, which is a fine codec in a lot of ways, but it was really designed to run on silicon, not really in software as much. So we find we can push about twice as many pixels a second to the screen using VC1 as you can with 264, assuming you have all the features in both codecs turned on, which means we can play back better mobile devices that don't have silicon. It means you're playing back on a laptop, you get longer battery life playing back VC1 and Windows Media. Good stuff. And lastly, maybe one of the biggest factors is there's so much content out there in Windows Media. Windows Media has been by far the dominant format for enterprise use. Pretty much every CEO webcast and HR training videos, that's all been Windows Media for a long time. It's the leading web format for many years as well. So by adopting Windows Media, we're just able to use all that stuff that's already out there and not make people recompress, because recompressing is painful. So from the compressionist perspective, video audio and Silverlight, broadly speaking, it's just Windows Media. You know, you have a simple WMV file on a server somewhere and you got a URL to it. You can take that URL into Silverlight and it will work into Windows Media Player. It'll work in the Windows Media OCX. It'll work. So you don't, so really the same ecosystem and the same infrastructure you might already have just passes on over there. So the new things we've done is great is we've baked all the media features into the runtime. So Silverlight itself contains all the video and audio codecs on any platform. So as long as someone's got Silverlight 2 installed, you know which codecs they have available. You don't have to worry about debugging DXVA. You don't have to make sure they have admin access to download codec updates, all that kind of stuff. If they're on the Mac, it's all built in there as well. So once you've defined Silverlight as the baseline, you know what the baseline for codecs are going to be. You don't have to worry about walking users through how to get those updated, which has been a pain point in the past. On the video codec side, we support Windows Media Video 7, 8, and 9, and also the 9 Advanced Profile codec. That's by far the majority of the content that exists today. If you're making content targeting Silverlight specifically, the 9 Advanced Profile codec is the appropriate choice because it gives the best quality and most efficient encoding there. 7 and 8 are really for legacy use, playing back old content. On the audio codec side, we've had Windows Media Audio, the original flavor, if you will, in Silverlight 1, which is a fine codec. The thing I'm very excited about Silverlight 2 is we have the new Windows Media Audio Pro in Silverlight 2. That about doubles the compression efficiency in the 32 to 96 kilobit range, what we had before, compared to Windows Media Audio, which is already a little bit better than MP3. So you expect that a 48 kilobit WMA Pro 10 in Silverlight, so the sound about as good as a 128 kilobit MP3. So we're talking about 2.5, 3 times better than MP3 audio inside Silverlight, which is great, which means like a web radio station, you can have absolutely danceable music at 48 kilobits. You can have FM quality down to 32 kilobits. So a big improvement over what's happened before. For audio-only applications, that means a huge bandwidth savings, or if you're bandwidth limited, a huge improvement in quality. And for video scenarios, that's the bits you save on audio or bits you get to spend on the video to improve the video experience. Works there as well. Also, MP3 files are supported as well inside Silverlight, so if you have existing MP3 content, those will play as well. So Expression Encoder 2, we're announcing, I believe the beta is now available. I'll be have the lovely experience of showing you a brand new 4-hour-old build at a live demo today. So it'll be exciting. I'll be on our toes. So kind of where we think Expression Encoder 2 brings a lot of value for some different markets. For designers, it's a great tool for being able to deliver your content in a really high quality fashion. A lot of traditional compression tools really require you to know, this source is 16 by 9, interlaced top field first, 29.97 and with this kind of audio, and you had to like kind of describe your content a lot and then tell it how to transform it to what you wanted to have there. With version 2, you can kind of drag a file in. It's being a computer and having the file and kind of figure that stuff out for you and kind of does the math and goes, well, you probably wanted your video to be the same shape it was in the first place, so how about I make your circles stay circles for you and not bother you with doing a whole bunch of time in calc trying to type out to get things to be like they were before. So higher quality and a lot lower aspirin budget, and that your first encode is a much better chance of actually looking like your content than previous tools have done. On the developer side, we're exposing a programmable object model for automation. So you can actually, in .NET, program a massive workflow, build a farm these machines, and it'll just process high-volume videos, controllable way. And because of that ability to read the source, it can automatically make the right choices how to process your video. When you make it programmatic, you don't have to have some big database that explains what every video clip is like. It'll figure that out for you on the fly, even in the automated mode, which is always one of the big barriers to doing automated encoding before. On the business side, it's much faster. It's up to 4 times faster on a multi-core machine compared to Expression Encoder 1. That's a mass improvement. Part of that's general optimization. Part of that's the new VC1 encoder SDK, offering better quality. Lower bandwidth cost for the same quality level. Combination of better source video processing and our improved codec implementation means we're able to deliver the same quality with fewer bits. And that's great because that means either you get to expand your audience by lower your bitrate requirements and you save some money, or you get to make a better looking experience. And done a lot of work around the whole user experience. For an operator, they can do a lot of great stuff. You could drag a file in. While that's encoding, you drag your next file in, start tweaking its settings, all that kind of stuff. So there's a lot less bartending, if you will, sitting there in front of the workstation watching that bar go from left to right until you can do anything else. So let one operator get a lot more done in a day. All right, so I want to show you, with great fear and trepidation here, a couple demos of it. So, does that work here? All right, let's see how it. Okay, so, Expression Encoder 2. Has anyone seen the new version yet at all? Any form? All right. It's good stuff. You worked on it. You don't count. That's it. So you know me from past stuff, but I've been a compression nerd for about almost 20 years now, and I used to consult a lot of compression tool vendors over time and always harangue them about features I wanted to see there. And I consulted in about 80% of the tools in the marketplace today on the user experience and all that kind of stuff. And I got to say, there are features in here I've been begging people to do for 7 years. And this is the first tool that actually delivers on a lot of these things here. So I'm going to show you the simplest. Actually, I'm going to show you totally a side of a demo here. I just love this one thing. So 1920 by 1200 display. I'm used to using big screen monitors, but I had to demo on these low-res 1024 projectors. And for compression tools, they almost all stink because they're designed for these big screens. But I get this guy here. I can, on the fly, change the size of my user interface to match the screen. I know, totally not related to compression, but 85% for demos. I would have saved myself hours of a time in control panel trying to adjust things with that. All right. So, user interface, blah, blah, blah. I'm going to go, let me grab a file here. What's a good file like? What's something I made recently here? Blah, blah, blah. Here's like a DVD file. Things that open. Opens it, analyzes it. I talked before about how it looks at the file, understands how it works, kind of figures out the right way to do it there. And it pops in, and if I want to, I can look at it and say, hey, why don't you scale to the size of the screen here, and I can kind of zoom through and look, okay, that's a video file here, all that stuff. But really, all I need to do at this point is go over this, pick the stream broadband preset for me, all that kind of stuff. Oh, profile adaptive support, auto deinterlacing. All those things are, it's reading my source file, and it's going to figure out, give me an output file that's the same aspect ratio of my input. If my source is interlaced, deinterlace it. If it's not, leave it alone. I don't have to touch any of those things. So from an operator perspective, really my experience can be, I can delete that file, I can import, I can grab a source file, I can hit the encode button, I can get some coffee, and it's actually making a file. And unlike any compression tool in the history of humanity, let me do a Julia Child here and just skip to the actual encoded to thing here. It's pretty fast, it's about a 7-minute clip. This is the exact, oh, wrong one. Tall ships. This is the output I'm going to get from that. In this case, I didn't apply any skins. It's just a Windows media file here I could upload. So there's a little blue blackness here. Come on, play back. Hello. There we go. So, do we have any audio here going on? All right. Maybe I forgot to do the audio. Anyway, so that's a pretty good looking video. Have you ever used Windows Media Encoder and just said, here's a file, just go through Windows, say default. You're going to get a jumbled mess to the wrong shape and all that kind of stuff and look horrible here. I just picked the default, and here I got pretty good looking video. This can go on a web server or a streaming server. It's going to stream pretty well. I can see ropes here. You're not seeing a lot of blockiness going on here. So from the get-go, because it's able to read that source file, know what the structure of it is, and make the right choices for you. So it's as simple as that. I could have had 1,000 files applied to the same thing. I could have used .NET Object, wrote a big thing to distribute these files across a dozen workstations. It all happened in some back office in Tulsa somewhere. And it would give me this kind of quality output. If my file had been 16 by 9, it would have just made a shorter video frame. It wouldn't have distorted the images there. So if you've done a lot of compression stuff in the past or taught compression classes, that is just a great thing to start out by not messing up and go from there. So, all right. So the things from that is basic encoding is super simple in that you don't really need to mess around a lot to get a decent baseline thing. There's always things you can tweak there. But generally speaking, you can just start out, you get good results from your first encode, which has never been true to any product before. So this thing I want to show you kind of more advanced, wrong thing here, demo here. We actually would do some tweaking and kind of show that experience. All right. So this is a high def file. This is a 1280 wide video frame here. And by default, so see, it's still doing the streaming broadband. But notice how it actually changed the shape of the window. It actually is now a widescreen video file because my source is widescreen. It analyzed it and figured I probably wanted it to be something like that. But, great, good start. But in this case, I have a scenario where I'm not really doing streaming. I want to do a high-def movie trailer progressive download because I'm doing a movie trailer site. And I know Apple movie trailers run around 6 to 8 megabits or whatever, and I want to show off. So I'm going to do a movie trailer at 2.5 megabits. Let's do about less than half the bit rate of competing movie services. Pretty good. So I'm going to talk about some of the advanced parameters we do for that. So we have a frame rate, same as source. Such a lovely feature to have there. Whatever my source frame rate does, just copy that through. That's almost always the right choice. And pick some codec options, modes. I'm using VBR for this. And say I want my video file to average, so I wanted to do 2,500 total, so do 2,400 for video, leave 100 for audio, and do a peak bit rate of about 4,000. I happen to know the Silverlight client. Generally, peak bit rates of 4,000 or less play back well on a Core 2 Duo laptop. I can go lower if I wanted to have a bigger number of sheets to play back on. And I could just say, I want to be 1280 by 720. Oh, look at that. Dennis Miller is very large. I guess shrink it down a little bit or whatever. Small here. Notice, even though I said 1280 by 720, it's actually not 60 by 9. It figures out, well, that's the biggest thing you wanted, but because I was profile adaptive, it actually said, okay, well, I'm actually going to make it match the smallest size that fits in that width that actually holds all your content. Huge time savings there. I could also want to say profile, and then it would actually add letterboxing for me. Oh, so sometimes you might want that. I don't recommend letterboxing because Silverlight's extremely good at drawing black rectangles, so might as well let Silverlight do that instead of the codec. We're going to say be the same as the source exactly. In this case, that's fine because my source is 1280 by 528, so good options there. Audio, got a default, which is pretty good. All that, I can drill down again. I don't need to, say WMA Pro. I can do, so variable bit rate is good for downloads, like VBR. I'm going to do 128 kilobits, pretty good. And I could say, give me a peak around 256. So what it'll do is it'll keep the average bit rate small, reasonable, but for hard bits of audio, the bit rate go up. For easy parts, it'll let it go down and give you the same file size average. That sounds pretty good. I got other options. There we go. For deinterlacing, in this case, I could turn it off because I know my source is progressive. But the auto mode figures out, oh, well, it's progressive, so it'll just not do anything at all. It adapts based on the source. And if I'm a big codec nerd, and I hope I've established I am an enormous codec nerd, Of all these advanced features from the VC1 encoder SDK we recently released, all the enterprise compression tools will be adapting this functionality as well, but we spent a lot of time on how to refine kind of basic presets of that. So one thing we just have is video complexity settings from fastest to best. So you just pick best, say, I don't care how long it takes, make it look awesome, or you can say fastest. I don't care how it looks, I need to get to my client in 3 minutes, or somewhere in between the two. And the kind of the normal, we've done a lot of work to figure out what's, it's pretty fast and really pretty good. So you can drill down that level, or you can dive down and have a lot more options you can pick up. So you can say, I want to be, better quality there. And for example, like, I have film grains, so I want to turn on the adaptive dead zone functionality and the overlap filter and all this I'll talk about later on. But, if you have a codec guy that can go through and really drill into settings like this and all that, adaptive motion range. So something like that would work. And also can go, hey, I want to apply a skin to this. I want to have actually the Silverlight experience and make sure that it's, kind of an appropriate browser thing. So these templates here, I can go, I want to pick out, what's a nice one? Corporate silver, I'm kind of fond of here. I'll see a little preview here of just a little clip here, and it shows me what the player I picked is going to look like. You can say that, and it's, and it'll do that, and it'll render it out for me, leave a preview in a browser, hit OK, and hit encode. This is an HD clip, so it'll take a little while to encode. So I'll Julia child this again, and I can show what the end results are. Progressive download. All right. So, and just a web page. Like in this, I can upload this whole WAD to a web server. This progressive download, it just needs to be a web server. Pop it right there, and I'm good to go. And it's really a one-click thing. I didn't need to go into Blend or Design to build it. Now, I could have gone to Blend and Design and modified the template and added my own graphics and done all kinds of awesome things. But I'm a video nerd, not a design nerd, so I would have someone who knows how things should look like do all that.
I don't want to marry you, Joey, but I'm leaving you. Well, I mean, this is my place, so technically you would be the one that has to leave.
Joy just got dumped.
Jack, you're fired. Don't get me wrong, you're like a son to me.
Dad, I am your son.
Jack just got.
So, there we go. And it's only a few clicks. All that stuff you can put in a preset here, and you got 100 movie trailers. You can set them up like that. Take a little time to encode, but it's easy to do. And the quality good is amazing here. This is again only about half the bit rate is your typical web movie trailer. You'll see a movie trailer website, and it's perfect. You're not seeing any artifacts. The screen here, there's more visual detail on my hard drive than the screen could display in the end. This is only 1024 wide. So, thematically appropriate as, thank you, Fox, for providing a Vegas-themed movie trailer for us to use as a source for the straight show. So, I'm going to double-click the whole web experience there. We got nice, crisp random access. So, good stuff.
Would you be the one to end the marriage?
Not only would you get out of the marriage,
get the full 3 million.
There. So, we had movie trailers work on Windows Media for a while here, but by having the whole nice Silverlight skinning experience, we don't have to have the user know, if you hit Alt-Enter, you can go to full screen. They can double-click, or you have a button for it. You can create a whole branding around how you want to deploy your video, but yet, you have a great codec underneath, easy to use. All right. So if I did that well, this time I'm not going to be dumb. I'm just going to skip the frame we wanted. All right. All right. So, take homes. Silverlight can do a great HD experience. I think we're the first plugin that can really do HD content with decent performance. We've done the VC1 was designed by Microsoft to perform well on Intel architecture processors. That's one of our core design goals for it. So we're able to get our quality per megahertz of your computer we can deliver is a lot better than competing technologies. So, good stuff there. When you can tweak settings to get optimal results. The presets are good, but it's one of those things, if you're spending another 5 minutes on a clip, you can maybe get a 10 to 20% improvement in terms of letting you either lower your bit rate or improve your quality, when that makes sense. And the nice thing is, then you can save those back as a template. So, you get your recipe for the perfect movie trailer down once, great, you just, then you can do 100 of the same setting, you're good to go. So, so when you get those improvements in efficiency, you get two ways you can do it. You can either lower your bit rate overall, or you can get better quality, and kind of goes back and forth. Most movie trailers look pretty good. So in this case, we're able to reduce our bandwidth costs by just make a smaller file, and also by being more efficient, we're able to have it play back on more machines. Because the higher the bit rate, the higher the the requirements for the machine to play back are going to be. So all those bits that we save are saving both money and also increasing the audience that can play that file back. The variable bitrate VBR encoding is a great thing there because it lets us specify an average bitrate and a peak bitrate. We can define our peak bitrate based on what kind of machine should play it back, and then we can lower the average just so the easy parts of the video don't go all the way up to that. Make our total file size, our total bandwidth costs go down significantly. So last one I'm going to do is screen recordings going all the way up to the Silverlight streaming website and talk about that workflow. So who has ever used the screen codec before for Windows Media for all that? So one thing that's come up is Silverlight does not include the screen codec natively. And a lot of people said, well, I got all this existing content in the screen codec and I want to publish it in Silverlight. Why don't you let me? And that's a fair question. It's the codec's not very portable and it's kind of a pain to actually get work inside Silverlight in a good way. But a broader thing is the screen codec is really tuned for Windows 2000. So if you're running, the old classic UI, it can record reasonably well. But when you talk about a modern OS like Vista or Mac OS X, which has a lot of transparencies and effects and smooth anti-aliasing, the screen codec doesn't work very well at all. And it's actually, if you think about it, it looks more like if you imagine an actual Vista screenshot, that's mathematically more like a photograph. You have smooth edges, you have some detail, some areas of fine detail, areas of flatter images, that kind of stuff. And so a more natural image tuned codec like VC1 actually does a better job of encoding that. So let me go back in here. I'm going to just delete this guy. I miss Dennis Miller being funny. He was so funny for so long, but it's all gone. All right, so here is a Camtasia AVI file here. Camtasia users out there? I love Camtasia. Great stuff. All right. So here we go. And this is a big old file here. This is a 1024 by 768 file here at, Anyway, all the panes are scalable, of course, here. Well, and this would take a lot of data rate to encode typically before. So, I got to think for a lot of stuff, if you get to 400 kilobits as a data rate, that's good. Because if someone's got a 512K DSL, you can give them 400 kilobits, and it's still going to look pretty good even when they're downloading their email. So I'm always happy when you get to 400 kilobits for a bit rate. So can we do a 1024 by 768 video with all this like fine detail going on and that kind of stuff and that? So the easy thing to do is you can just go, hey, let's pick a, where is the excellent screen encoding preset? All right. So and here you can see the amount of sharp edges, all that kind of stuff in the source there. And we can be good to go with that. And it's pretty darn good. But, if you want my secret sauce, we can go do even better. One thing we can do in the frame rate is, sure, we can play back
www.root folder.
5 frames a second. Let's get the full smooth motion. I'm going to go 15. But again, I can pick source for that. I think, I make my keyframe interval really broad because things don't change a lot in the screen recordings that much of this kind of content here. I'm going to go to VBR. So if I want to target this for Silverlight streaming, so the whole free service. Silverlight streaming wants a maximum bit rate of 1400 kilobits for the peak. So let's say I save 100 for audio, I can say 1300 for video, and my average for audio 48, so it'll give me 300 for video, for 350, and that'll give me my 400 total I want to have for my file. So this will be a file that'll, someone's got a low-end DSL, they'll be able to play back in real time, off Silverlight streaming, so I don't have to pay for my bandwidth, and life is good. So it's 1024 by 768, same thing there. On the audio side, this is where the WMA Pro codec gets in. So the audio here is pretty easy.
The tree at the left to be able to see the various websites.
Yeah, that's a good job with it, but it doesn't need a lot of bits here. So we can squeeze this down in VBR mode. I'm going to take this down to 48 kilobits of audio. Historically, 48 kilobits of audio, even with voice content, sounded pretty bad, but we're going to make it perfect. And I can say 48 average. I can say, give me up to 96 peak. So 96 plus my 1300, about 1400, which is the limit for Silverlight streaming. So my overall file will fit within that pipe. Good to go. Blah, blah, blah. That's all easy. And I drilled on some of the video features here. I would talk about why later on, but I turn on iframe dequant, and I turn on full true chroma, and SAD's fine, and then my data. So one thing I should warn about this is if you're doing screen recordings, turn clear type off. if you're doing screen recordings, you want to do it. I mean, you can use normal anti-aliasing kind of functionality, but the clear type feature, uses the kind of the subpixels of LCDs to do a nice job of smoothing the text out. But when you zoom in, you actually see some weird color fringing around the letters here, a little bit. So you see little blues and little reds around there and all that. And when you make that put that clip back on a different LCD display, it'll look kind of pretty bizarre. So you always want to record your video, your stuff, just without clear type with like the normal screen scaling mode on, smoothing mode on. It'll both encode more efficiently because you don't have all those little color things in there, and it'll look better on more display devices. And that wasn't done with this clip, and that's okay. But that true chroma search will help us adapt that somewhat there. So the other cool things we can do is, this is a long clip. This is 10 minutes long, all about configuring a server for media stuff. People probably want to know some stuff about where things go. So I can say, hey, I'm going to put in some markers. So I can say, on the very first frame, I can say add a marker and say this is going to be the start, and make that a keyframe, make it a thumbnail. I could do access to it later on. I also have script commands and say, I would actually say, right here there's a caption, and the person says, hello, welcome. But I'm bored. So what I'm really going to do is I can go through and say, I made an XML file of markers. So it's portable. So if you have a authoring system that can give you a list of subtitles or markers and a lot of things, you'll get that often in typical video workflow, like SAMI files or whatever. So captions exist for a piece of content. You could then import them. I'll import my captions too. And I've got a list of kind of random things I typed. So it's not very good. But so we have a list of markers, which we can use for navigation. Say these are all points that will become places you can both jump to because they're keyframes, and that will get a thumbnail for in the Silverlight skins you can navigate to. And then also we're able to down here have captions, so it'll tell you as someone's talking underneath. So if you're in government education where you have accessibility requirements, you're able to get subtitles on your video. So all of a sudden, you're able to then provide that accessibility in that regard. So now also can say metadata like it's IS7, like posting new content, and you get stuff like that. And we have this incredible list of other metadata items you want to do. And when I'm feeling cheeky, I'll often sneak in. So if you ever get really bored, you can download clips off Microsoft.com and find out which ones I did myself. So, and things like, say, I want this first frame here. That's going to be used for my navigation here. I can pick my skin that's got, different ones for things like Quicksilver or whatever. They give me kind of cool animations, and I'll be able to get all my thumbnails and do it all here. Then if I have a Silverlight streaming account, it's simple as I can say Silverlight streaming. I'll publish here. It's got my account name already propagated. Remember that? I'm going to say, call this, IS7 clip 4, and I can hit a code, and it's going to compress the entire clip, and then it'll automatically upload to the Silverlight streaming, and then it's already published. So I can actually do a batch of these. I can do a dozen clips. I can go away for the weekend. I can log it on my phone to see if they got posted or not, and then it looks like I've been very busy when I'm just slacking off. So my dream as a compressionist is to make everything so automated I appear to be incredibly productive while I'm playing on my Xbox. And unfortunately, I have to write emails in my job, so I haven't figured out the email AI yet. But at least I'm able to write more emails in a day now with this instead of having to babysit my encodes. So again, I'm not going to do the entire encode here. We're going to skip back to demo. IE8 beta, by the way.
Hello, and welcome to this video series about using Internet Information Services.
Oops, where's my... Oh, is this the wrong one? I'm sorry, I think I did two different versions of this. Progressive today. Oh, there we go. Sorry, I re-encoded it. No, that's not it. Is that? There we go.
Hello, and welcome to this video series about using Internet Information Services version 7, also called IIS.
So I get all my cool things there.
Techniques will be shown on Windows Vista, and you can also do the same things with the version of IIS 7 that's found in Windows Server 2000.
So that is 48 kilowatt audio. That sounds perfect. So nice. I mean, one of my beliefs right now is with good audio codecs, you have enough bandwidth. There's never any excuse for your audio to not be awesome. So any kind of encoding you do, the audio should be awesome as a baseline. You want to make the video as good as you can with that, but there's never any excuse for actively, distractingly bad audio anymore, because 48 kilobits will do it for you for almost any content. Pretty good. And you can do great music sounding, you know, disco level music audio about 96 kilobits now, in my opinion. So here I set, remember those thumbnails I set there, and I get little thumbnails. So I just go here and get this random access. You know, and so people can look at actually visual thing of what part of the video they want to look at, automatically generated for me. I can go back here and my captions should show up at some point wherever I put them in. Are we playing here? They were up there a second ago. I saw the captions. They're really there. Or did I? All right. They're in there somewhere. Oh, also the nice thing is you actually can go full screen. The nice thing is I encode it at 1024 wide. The screen's 1024, so go to full screen. I'm actually in perfect pixel alignment. If you look at this quality here, this is 350 kilobits, which would not have been enough to do a QVGA 220 by 240 movie trailer 5 years ago. And if you didn't know this was compressed, you probably would think this is actually a live screen demo. But that's a file that's running, you know, the video's, again, 350 kilobits. We're good to go. We have good random access. I'm psyched. So literally, if you look really carefully around the views right there's a little bit of blocking right about there. But I can only see it in the screen here. So there you go. Oh, whoops. All right. So takeaway from that particular demo. First, Silverlight can give you very nice, rich presentations. We have those chapters with the icons. We have subtitles. And as a video guy with very little creative skills, I was able to actually just use the skin. The stuff got in there. You can jump around. It worked for us. You got subtitles. You're doing captioning. You have accessibility story right there. You can use existing files out there. You can add them yourself if you need to. Easy to do. Also, VC1 is now a great codec for delivering screen content with modern UI experiences. So I'm sorry we didn't get the screen codec, but this will be better. And you can re-encode screen content to Silverlight. You're good to go. And lastly, Silverlight streaming is a great platform for getting the stuff out there. I mean, after clicking that, if we had a better web connection here, I'd go back to the server and show it to you, the actual playing back. But that whole experience there, you know, for a free account, I can publish content straight from the tool of that kind of quality. You know, it took about 25 minutes to encode that 10-minute clip, the final thing. So, you know, we could actually, you know, it's about a third real time. So you can start publishing hours of great content pretty quickly. Okay. So this next part here gets kind of more of the technical aspects of compression stuff. So if you either are or aspire to be a compression nerd, you may enjoy that. If you don't care about knobs and dials, you could check out another session if you want to. I'm not offended. Oh, if I bore you, this is my stuff here. All right. Talk a little about kind of the general best practices around capturing, preprocessing, and coding, and then the advanced codec settings we have access to. So these things are not expression encoder specific. Any compression tool you use, these all matter. And we're working with all the other compression tool vendors to get that new VC1 SDK in there so those new codec features are available to all the products in the marketplace. And again, we do best practices of the encoding side. We've got three kind of core goals. One, make it look better. You know, that's better. But looking better, sounding better is always a good thing. No one likes artifacts, especially audio artifacts. We want to improve our compression efficiency beyond that. So better quality, the same data rate, same quality, lower data rates, either way. And we're trying to really optimize that cost per minute of video on the authoring side and the delivery side. And you think about it is, you know, what is the dollars per unit experience delivered to the end user? You know, anytime you can get more experience per dollar you have to spend, that's better, because if you're media advertising funded, or if you're a video on demand scenario, you know, how much money you make is based on the experience you deliver. If you can deliver that experience more cheaply, you get to have more money when you're done with it. And we all like that. So again, the return on investment of good compression, one is a better user experience. So bad video and particularly bad audio is very fatiguing. If you have audio that it's or harsh or whatever, no one is going to spend more than 5 minutes watching anything that audio is actively bad on, even if it's pretty compelling. You know, one of the reasons why YouTube works is even though it looks horrible, the audio is actually mediocre instead of horrible, so it doesn't hurt people off. But a fatigued customer's going to leave sooner. If you make them tired by having to try to like look through your artifacts and listen through the noise to actually get to the content, they're not going to stick around as long. Also, as you improve your compression, you reduce bandwidth costs. Obviously, that is cheaper, but also by doing that, that increases the audience. If you have experience you were delivering at 1,500 kilobits, and then you can deliver the same thing at 1,000 instead, the number of people who have that kind of bandwidth has gone up, and so your potential audience for that has gone up as well. So, all good stuff. So, kind of walk through the workflow of it. First part of it, you want to capture content, and a lot of video gets irreparably ruined at the capture stage. I see a lot of stuff like, I had this great HD tape, but then I had my deck and I hooked it through S-Video through a DV adapter, and it captured as DV, and it don't look as good anymore. Well, yeah. So, kind of the dream is you want to be able to capture things as the digital native things. If it's coming off a tape, you pull it off the tape as native bits. If it's coming out of a video editor, then you want to actually just say, save this file from your video editor, use that file as the source. No chance for anything to go wrong. If it's an analog tape, it's like a VHS or Beta SP or whatever, you don't have something that's great, or even DVD, you want to get the earliest generation possible. If it's a DVD that was made from a tape, getting that tape is going to give you a better starting point than from the DVD. And you can do stuff that you can always put in more work to make a suboptimal capture better. But it's amazing how quickly you wind up spending more money fixing the problems caused by trying to save money in capture than it would have cost to have just bought a real video deck in the first place. So, so as we're just getting capture, making your capture look perfect, starting point makes everything much simpler down the road, and it'll pay for itself quickly. Next level is pre-processing, which is everything happens from the source video before it actually hits the final codec. So that's when you do your deinterlacing, your cropping, your scaling, if you reduce noise, if you take out letterboxing, you change the image aspect ratio. It's making sure the bitmaps that actually get encoded are the right bitmaps for what you want to deliver. And remember, all a codec does is it starts from the frame it's given and goes down from there. So if you process your video wrong, it's never getting any better than when that happened there. And I would say in my experience, for the projects that use a lot of my labor, pre-processing is where more of my keyboard and mouse time gets spent, in the sense of me actually having to make choices. The data rate stuff, you kind of know where you want to deliver it. You do that for a while. You kind of figure out what the right bit rates are. But if you have a source that's kind of messed up, Family Guy in particular is amazing how weird they made that, how they did the post-production on that. You can spend 10 hours making the 30 minutes of video look right, and then it encodes in 20 minutes. So, it's one of the things you kind of have to sweat. And one of the reasons I'm so excited that Expression Encoder does more of that automatically. An example, here's just a frame of video here. It's a typical capture frame where you've got letterboxing top and bottom. It's interlaced. You see all the horizontal lines. It's stretched out because it's a 720 by 480. It's 4 by 3 kind of thing. I take that frame, and then what I would do to take it in the encoder would be this, where I've made it proper aspect ratio. I've taken out all the black edges around it because I don't need to spend bits and CPU cycles and bandwidth on black rectangles, because again, Silverlight will draw those for me nicely. And I've fixed the interlacing, so you don't see those horizontal lines. And all of a sudden, golly, those are letters flying around there. You probably didn't notice those were letters before, a little R there. So, better thing there. The advantage of processing that video well before it's encoded is doubled when you actually compress it, because things like those thin horizontal lines, those are really hard to compress. So right now the codec is spending a huge amount of its bandwidth trying to draw those little horizontal lines right, which should have been there in the first place. And those are bits that don't get spent on drawing the motorcycle. So if I take it 1,000 kilobits, I can do that there. 800 kilobits, so fewer bits. So I use a lower bit rate, but cleaning the image up first, the same settings, I can get that frame there, and it looks a lot cleaner. So by processing my video well before I encode it, I can actually get away with better quality and better bandwidth at the same time. And that's free. So a couple parts of that. First is cropping. Video monitors typically don't go to the edges in traditional standard depth video, while computers do. So often there's just junk around the frame or video frame that doesn't belong there. You want to crop that out. No reason to deliver stuff that's not image. Super low resolutions for like mobile devices or a little picture-picture window. You can even crop in tighter than that, what's called into the safe area, which is part of the edge of the window that people thought nothing might be there. I also want to crop out letterboxing as well, so no reason to code that. Like I said before, it is excellent at drawing black rectangles. See, so yeah, there I spent this whole time there prefacing my own slide there. So this is kind of a video frame here. It's a little black stuff around the edges of the video frame. The active safe and title safe are two of the safe areas. So typically there will be no critical image information that's in the border outside the title safe region. So you can actually crop pretty aggressively without losing any actual image data most of the time. Scaling, that's how you make the image the proper shape and size. Doing low bitrate stuff, you want to make the image smaller. If you have an HD source, you want to encode to a 300 kilobit connection, you're not going to encode at 300 kilobit HD. You got to make it smaller, like 320 by 240, something like that. And also, if your source is a non-square pixel thing, like a lot of standard F videos is 720 by 480, you want to be able to make it the right shape. So one of the canonical problems you see people make is, I've got a 720 by 480 source, I want to make it smaller. Then I'll make it shorter, so I'll make it 240 tall, and that makes sense. And then I'll make it thinner, so I'll make it 360 wide divided by 2, and that's always wrong. Because your image is really either 4 by 3 or 16 by 9. 720 by 480 is a non-square pixel video frame. So if it's 4 by 3, 320 by 240 is a good size. If it's 16 by 9, 432 by 240 is a good size. But 360 by 240 is never the right size for any video. And a surprising amount of user-generated web content is actually done at 360 by 240. And it's so mathematically compelling, people are drawn to it like moths to a flame. But it's like the flame, it burns your wings off or something. So if you go through and do it wrong, it's kind of subtle here. So this is kind of what a frame looks like. You look at 1:1, make it 4 by 3, it looks about right. Make it 16 by 9, stretched out a little bit. Depending on what's in the image, it can be kind of hard to detect how much it matters. It's one of those things that when you see it right, you go, oh, that's clearly the correct one. But when it's wrong, you might not notice it right away. So the things you want to look out for is any kind of circles and squares in the video frame. You see those, you can really tell whether those are not the right shape or not. So you kind of want to look out for, like, letter O is a nice one anywhere in your video frame to see if you got that wrong. So same image, 16 by 9, that would be what it will look like in the video frame uncorrected. Make it 4 by 3, it looks terrible. Quite common on YouTube, by the way. You'll see a lot of those videos. And then done right, stretched out wide, like that. So there's a lot. So in expression codes, which are scaling modes in there? I would argue too many. This confuses. And it might, huh? Well, I asked for the bottom 3. You left the top ones. So the ones you really want to use, for the most part, are the first 2 because they're bad. Bicubic does a good job of scaling, generally. If you're shrinking size, you want a little sharper, a little more poppy image, Lanco scaler, it's a little bit better, not a huge difference. If you're trying to upscale, the super sampling mode is good, but you don't really want to upscale because, again, Silverlight can make a bigger rectangle for you pretty nicely. So you're typically just wasting bits. So I probably 90% of the time use bicubic, just because I often don't want to get too much sharpness on my output frame, and does a good job. Again, like the pre-processing example I gave before, scaling poorly hurts compression too. So here's a poor scaling thing, again, versus having, oh, that's my things on there. Anyway, so if you look at, see how the pattern in that circle there, you get sort of a moire pattern deeper in there. When you scale things, you get detail that didn't exist because it wasn't processed right. And when you do it correctly, see it just kind of fades off into gray as the black and white average out. That's what you'd expect. And that isn't like that wrong exactly until you've seen what it looks like right and go, okay, that's really what it should look like there. When you go in the encode side, all that erroneous detail, again, the bits get spent by the codec on the wrong stuff, and every bit that gets spent on an artifact is a bit that doesn't get spent on your actual image. So you wind up with, in this case, more artifacts having scaled it badly than you do by scaling it well. If you look around the circle there, you just you get more artifacts in source. And the after is actually a little bit smaller file as well. So again, one of those cases where by processing your video right before you encode it, you can get improved quality and improved bit rates. Last major thing here I'm going to talk about is deinterlacing. So traditional video is shot interlace, which means every other line is captured half a frame duration apart. It's kind of so if you ever, remember the old VHS players, you'd hit pause and go, if you're 35 or older, you know what I'm talking about. And there's the positive would skip. And what's happening, you're seeing the even lines and the odd lines and the even lines and the odd lines of the frame going back and forth, and this weird pulsing thing. They fixed that later on because it was annoying. But so we don't want to encode like that, because horizontal lines made sense in the weird video format. It was a very clever hack in 1937 to deal with like video technology back then, but we've been stuck with it for 70 years. So we need to fix that. I'll show you why in a second here. Expression encoder has this nice auto modes. I really like the auto pixel adaptive mode, which figures out whether it needs it or not, then applies it. And then the adaptive mode then does a really nice job of cleaning it up. The Bob mode is faster, but a little lower quality. So I tend to think I've got, whenever I encode anything at less than the absolute perfect setting, I always wonder, but if I did it better, would it look better or not? So I just skip to the slowest, highest quality mode, just because that way I don't have to do it again a second time. So typical interlacing looks like this, where there were basically two parts of the image are captured at a different time. So your even lines and your odd lines show a different image. Where things aren't moving too much, like in the foliage of the tree, it's not offset by too much. You got to drop in a bucket in someone's head, that moves faster. So flying buckets, almost like two kind of different ghost images. So if you encode that, that's going to encode really badly, because it's all the detail winds up being these little lines. A Bob deinterlacer gives you something like this, where you're going to see, it cleans it up like that. You see a little bit of jaggedness around all the edges. And there's no way around that. It's just illuminating part of the image here. A good adaptive or inverse telecine kind of mode will give us this nice clean output here, where you're not seeing all those kind of artifacts, and you get nice smooth lines like that. So, and again, every time you can avoid putting in wrong detail, that's bits that get spent on the correct detail. All right. So now, if you just give me a few moments of absolute pure codec nerdness, for those who really care, I'll do this in 3 minutes, and then we'll do Q&A. So bear with me here. So we have this thing we announced called the VC1 Encoder SDK, which I worked on for about a year, which is an advanced VC1 encoder that gets used for HD, DVD, and Blu-ray authoring, gets used for IPTV stuff, and also gets used for Silverlight. And that's built-in expression encoder. And it's faster, gives you a lot more control, higher quality overall. It's one of those things you just drop it in a product, and you get better looking videos sooner. It also gives you a lot more options that gives you more stuff. Let me give you some examples of some of the features you choose in that. It's an older mode we've had for a while, but we've tuned it up some. It's encoding mode. And in encoding mode, you generally have files either as a constant bit rate or a variable bit rate. Think of it as a constant bit rate. It changes the quality throughout the file to keep the data rate constant. In a variable bit rate file, it varies the bit rate to keep the quality constant. So generally speaking, a VBR encode will be more efficient in that it's able to reduce the bit rate for the easy parts of the image and spin those bits in the hard parts. While CBR, you get this, it's the hard parts don't get any more bits than the easy parts, and so they don't look as good necessarily if your bit rate's low. But the main reason we do CBR is because we have either streaming, because it needs to be constant bit rate for streaming to work, just a requirement, or if really our limiting factor is how fast you can play the video back. If you're doing a video clip that's on a local hard drive, you don't care about network speeds, and your machine can play back up to 4 megabit file, you can use the code as 4 megabit CBR, and you're using as much quality as you can get for that. VBR you use for progressive download, or in those cases where you want to have the file to be smaller than you would get if you just had the peak bit rate. So it really breaks down to streaming versus progressive download. We also have a parameter called complexity we do, which is a trade-off between speed and precision of the encode. Typically, each time you go up one level, it cuts the encode time. It doubles the encoding time. It makes the compression, depending on which level, maybe 3 to 8% more efficient. So it's not a linear trade-off. I wish it was. That'd be a pretty good one. But it's one of those things that going from level 0 to level 3 lets you save maybe 20% of your bit rate, which is could be very valuable if you have a file you're going to watch more than once. 3 is an appropriate default in that going from 3 to 5 it doesn't really give you a huge improvement, maybe another 3 to 5%. So I typically only do the maximum 1 if I'm doing videos for a trade show, presentation, or whatever. All of the video clips you saw at the keynote, I did all those as complexity 5 because I didn't want to, because I really cared. So I had time. I typically use complexity 4 as my normal default for kind of things I like a lot, but I'm not paranoid about. The vice president's not going to show. They get complexity 4, but vice presidents get complexity 5. So someday I'll make Steve Ballmer complexity 6, but it hasn't happened yet. In the live mode, the complexity actually is varied in real time to match what your hardware is. You don't have to specify it. It just happens dynamically. It's one of those things you kind of trade off in cost between spending more time in the encode, letting you save money on bandwidth. So typically, the more times the clip's going to get watched, the higher complexity you're going to use on the encode, because that lets you save a lot of money on bandwidth. Beyond that, we have some of these we call perceptual optimizations. This thing called adaptive dead zone, which I've always gotten on a T-shirt, because there really aren't a lot of really cool words of compression. But adaptive dead zone, it's not a threat; it's a promise. Basically, it's your film grain feature. If you have grainy content, it lets you preserve kind of coarse textures, like if you have film grain, you want to deliver that film grain. That does a nice job with helping that. There's we call mode called conservative that helps there. Turn it off with clean content. You use it with grainy content. A thing called dequant, which basically preserves flat, smoother areas of the image with really high quality. But by doing that, it spins bits on those, which can take away the other parts of the image. For most kind of video stuff, you want to leave it off. But for the screen recordings, for example, I use the iframe dequant to make sure what we call the keyframes, which only happen every 20 seconds, but are the reference frames, so the image changes a lot. You get one of those in. It's perfect. Then all the frames that follow that had a perfect source frame to start with. And that lets me save bits on all the other frames. So it's kind of a special use thing, normally off by default. We have a couple other settings. One is called, we have B frames, which are a bidirectional frame. And basically they do two things. One is they're a little more efficient for encoding, which helps. They make your random axis a little bit faster, so you can scrub around a little bit more efficiently. And also if you have them turned on at all, so it's not set to 0, but any number greater than 0, it lets you compensate for flashes and strobes, so your raves and your gunfights look a lot better. Anytime you have a gun flash or whatever, it keeps the video after that happening from falling apart. Important there. One is a default for almost every video film source kind of stuff. And then you asked about for animation stuff. I find 2 B frames lets me improve my quality a decent amount for cell and CGI style animation. And for screen recordings, I find 4 is a really good number. Let's really squeeze a lot of bit rates out of that way. There's some other options seen listed down below. Leave those as the default. Those are kind of on for that multiple bit rate adaptive streaming technology we talked about down the road. Those are kind of placeholders for some stuff that'll happen with that down the road. But that's not available yet, so don't worry about it. Some other options, we have the chroma search, which lets you look at how places where your hue or saturation changes without your brightness changing. Great for motion graphics and animation. Turning that on can really help really colorful content quite a lot. I tend to use the adaptive true mode a lot. Works pretty well. Motion message. If you have a lot of extra time, the adaptive mode there makes your video ever so slightly more efficient, and it slows your encoding down by like 30%. So it's kind of an anal thing to do, but I like it. Search range. The mode called macroblock adaptive, which on frames of video where the things move really fast, it actually is able to increase the range of the areas where it looks for motion between 2 frames, and so it's able to catch those. So for high motion video, it helps pick up those, but it's adaptive in the sense it doesn't have to do all that math for every frame. It only applies what is necessary, so it doesn't hit your encoding speed too much. So that's a good thing there. And you have a few filter options. One of the things I say you should always have on is the loop filter. It just keeps the video from getting blocky. If your video is still a little bit blocky, you can turn on the overlap filter, which smooths out the image further. It can cause you to lose detail if your video was clean otherwise. But generally, the bit rates you're targeting for Silverlight stuff, you might get some artifacts in some cases. So I probably use it about 80% of the time in Silverlight targeted stuff. There's also a denoise and edge noise removal filters. You only would use those if you have noisy source or noise around the edge of the frame. You're generally better off just having good video to begin with. But it's in there kind of for special needs. This is kind of an example of the motion vector search range thing here. You can see how the cue ball moves from there to there. If your motion search range is too small, it won't pick up on how it's happening there. But as your range gets bigger, it's able to pick that up. But there's a lot more math it has to do for that. So the adaptive mode just kind of will change that value frame by frame. Oh, I understand about that. All right, so that's my 70 minutes of video stuff. Yes? Yeah, microphone. Yes. Oh, there we go. We have microphones. Line up behind the microphone and ask questions. Excellent.
I think you'll agree that it requires a lot of experience to decide what encoding should be for a particular video. I work on a project, I have thousands of webcasts, and I want to encode them. Some are 300 MB, some are a GB, So how can I programmatically, I know you talked about automation of encoder, but is it an API I can use?
Yeah, so there's basically a .NET object model, so you can actually write a managed code wrapper around an exposed API of expression encoder. Anything you saw on the user interface level, you can then fully automate.
Okay, so is it UI-less, or I can
Yeah,
just...
there'd be no UI in that case. It would just run as a service in the background, and you wouldn't see anything. So you can set up a whole bunch of, you can basically make a whole big render farm based around that. We don't provide that layer, but the API is capable of building very complex behaviors based around
So
that.
for my understanding, right now I have to use the automation engine that you have and then build an API on top of that so that I don't show the UI of...
Exactly, yeah, it's a service.
Okay, thanks.
So.
Thank you.
Hi, I'm Dan. Can you protect your intellectual property when you use the live.com service to host the
Can you
media as
protect
far
your
as server-based authentication to the clients that are accessing it? Or is it
So,
just you throw it up there and then it's available?
I think once you're on, the service is architected for live.com. Yeah, just you have a URL.
We can use our own
I mean, you
plugins
could use
to
conditional
authenticate?
access in the sense that you don't give people the URL for it. I'm not sure there's any way to lock them. Is Remy here? Catch me later. I'll find some of the program managers for that. I'm not aware of any way to do that, but that's a pretty obvious feature request. I'm sure someone else has asked for it. So even if it's not possible today, that may be on the roadmap down the road. Certainly, we've got a lot of history in authentication and rights protection, that kind of stuff that could be applied to that down the road. So.
Hi there. This may have been covered in the first question, but I missed it. Do you have a encoding server, or does everything have to be done from a client? Like if you want to batch encoding jobs or something like that?
Well, I mean, there is a GUI batch model, so I could just keep on adding sources and it'll go through in order. But yeah, there's a .NET object model that you could build whatever you want to on the automation level, where it runs as a service, so you can then run multiple instances in a multi-core machine and do all the things you'd expect out of a service.
And it can run on like Windows Server 2008 or something?
It does. I actually, my primary expression encoder workstation is Windows 2008 server, actually. I run it in GUI mode on that because I need to do some screenshots of IIS, so I was like...
And do you have to be logged, like do you have to have an interactive login or not in order to run those jobs?
That's that question. You need an interactive... No,
Okay.
you don't.
You just run.
Yeah.
Cool. Thank you.
That guy, yeah. Charles I can tell you a lot more answers about that, yeah, but it's pretty awesome.
Yeah, I just wanted to clarify. You were saying to do your pre-processing before you do encoding for improved quality. Just as an example, say I'm using Apple Final Cut Pro and I've got a DV quality clip that, are you saying that I should use whatever that editing system is to say I've got to stretch it to 854 or maybe scale it down? Should I do that before I use something like the expression encoder?
So when I talk about the pre-processing versus encoding, it's really more kind of a pipeline thing. The expression encoder does them both in one product, even though it's mathematically two different operations. So it does a good job of that. But yeah, if you're in Final Cut, you can absolutely export the way you want to do it. And my preference, if I'm authoring something that I know is going to be an 832 by 480, 24 frame a second something or whatever, or a 320 by 240, 15 frame a second, if I know what's to be delivered at, I set my timeline in my editing tool to be that. So I don't have to worry about, did I deinterlace or is my text going to be readable? I want to have my preview window and my NLE exactly match what's going to go in the encoder. Because that way I don't have to be surprised about, I made my video small and now my text isn't legible, kind of stuff. So from a quality perspective, either way works. But from a workflow design perspective, I much prefer to have my design be happening in the actual native mode of how the video is going to get processed.
And then encoding is just a matter of keeping it as similar to whatever's in your
exactly,
as possible.
And that's one of the awesome things about expression encoders. You drop that in, it's profile adaptive. It'll just kind of pass through everything you're doing. You can even say profile, frame rate source, and frame size source, and it will exactly copy your frame rate and your frame size from the source file without modifying it.
Awesome.
And that gives you both perfect quality and also it's fast because it doesn't have to do all the math to change the image size. So.
Thanks.
Recommendations for bad, old, dark, analog media clips.
I'm always amazed how much at the end of the day I realize it's 3 in the morning and I'm in After Effects. But yeah, there I am. It's 3 in the morning. It's After Effects. I'm in 32-bit float mode, and there I am running the levels, controls, and 3 different filters. It's one of those things. The worse your source is, the more effort you put into making it almost mediocre in the end. But yeah, you have like your image levels are off. I mean, so expression encoders is going to give you like a lot of like gamma controls or that kind of functionality. So if it's just like your luma level is just coming in bad, that's where a tool like an After Effects or an editing tool where you can adjust things more really comes in. Logarithm's got some great noise reduction plugins I've had good results with. If you're using After Effects, there's the grain removal plugins. If you have more patience than some of us do, you put that in the temporal processing mode, it can take a long time. It can look pretty good. So, but yeah, it's one of those things you can be amazed how you can spend an hour to make a minute of not very good source video look somewhat better. But that's the way it is.
And training resources for the new stuff?
For
what you're talking with the Silverlight piece of it for today?
On the encoding side, what do we do? There's some stuff online. I teach a class myself, a week-long seminar at Stanford University every summer. It's a week-long intensive about all this stuff. If you're really, really not sick of me yet, okay. But that's good. But yeah, what do we? Yeah, total training is going to have some stuff up there. So
thank you.
And this will be the last question here. Thank you.
Yeah, that 1400 kilobit limit that you were talking about imposed by Silverlight, is that just an observation?
That's specifically the Silverlight streaming service. The Silverlight client software doesn't have any limitation. So if you're using, a different CDN or your own server, you can do other values. Okay. My rule of thumb is I like to keep my peaks under about 4 megabits to give good performant playback for HD content on a Core 2 Duo machine. The lower your system requirements, the lower you want to have the peak bit rate in order for playback reasons. But okay. Yeah, the 1400 thing, that's a Silverlight streaming specific limit of that one service.
Right, is that WMS you're talking about, or a different service you're talking about? Or?
Yeah, this is streaming.live.com, which is kind of a service we provide. But if you go to like an Akamai or a Limelight, they'll let you do whatever you want, or your own service. Alrighty, and I think we're out of time. Good. So I'm going to hang out here if you have any other questions. But